Now we'll take a look at some other things that we can do with loops and also how to protect yourself against an infinite loop, so a loop that continues forever. So in this program, we're going to start with number count, and we'll be counting this up. So I'm going to create a while loop here. And the condition for this loop is going to be 1 equals 1. This is an infinite loop. It will never end. There's no scenario where the number 1 will not equal the number 1, so it will just keep looping. This will always be a true statement. Occasionally you can use this, although it's usually not recommended to use this method. So what I'm going to do here is I am going to increase the num count every time. And then what I'm going to do is I'm going to print it out. So system.out.println num count. Now, let's take a look at what this is going to do. And it's always a good idea to make sure that you've got it saved before you go ahead and do this. Sometimes it has a little bit of a difficulty thing. So I'm going to save this as breakout. And then when I'm running it, here's what we get. So it might take a minute to kind of catch up to what is happening. See, I've got my first output, which is a 2. But then as the display catches up, what it's doing is it's just growing infinitely. So I imagine the same amount of lag with the next one. Because if you consider the speed at which it's generating these lines, the display sometimes on the browser version of this just cannot keep up. So 3, 2, 1, I'm going to just stop it here. Okay. So now what I want to do is we want to consider, okay, well, what actually happens if this number grows infinitely? So I'm going to change this to num count gets the value of num count plus, I'm going to put 6 1s here. This should grow a little bit faster, and I'll save it again and then run it, see what happens. So now that I'm running it, so let's see what we get. So you can see that the numbers are quite large almost instantly, as this thing is able to display them. Now, what's going to happen? It can't take up infinite storage, right? There's no way that we can display a number here that is larger than the storage space of your computer. Much less so that this website. Oh, so take a look what has just happened. It skipped from a very large number to a very negative number. And we did this by addition, which is the strange thing. So I'm going to stop that. So what happens is when it gets to the largest number that an integer can possibly store, so it's about 2,400,000,000 something, when you add 1 to it, so imagine that 2 billion was the largest number that you could store. If you add 1 to that, so when we overflow, this is the term for it, the number becomes negative. So you switch from the largest possible positive integer to the smallest possible integer that you can store. So that's obviously something that you have to be very careful of. So now what I'm going to do is I'm going to turn these two things into comments because we don't actually want them in the program that we're going to create. So what we're going to do is we're going to make just a little game where the user has to enter numbers that are larger than the last number that they entered. So we're going to need a number for this, and we're going to need to remember what the old number is. So what I want my loop to do is I want it to make a comparison between the new number that the user entered and the old number. And if the old number isn't, sorry, if the new number isn't larger than the old number, I want the loop to stop. Now, this requires both numbers. So here's a rare case where you can't actually include this entire process inside the loop. We have to initialize it with this. So we're going to prompt the user. So we're going to say enter number, and then we will go plus num count plus, there we go. And then what we're going to do is we're going to store this in old number. So that's input dot next int. Okay. So that's step one for this program, is we actually need to initialize this with what the previous number, because we can't have this cut out of the loop until after like the second number gets entered. So now what we're going to do inside the loop, this is where we are going to go num count plus plus, because the next one that's going to get entered is the second number. We're going to repeat this process here. And then instead of old number, we're going to store it in number. And then what we need to do is we're going to put in a new line here, which I don't really like using, but there are scenarios where you know, it can make it very clear what's happening in your program, is we're going to use a break. So if the number is ever less than or equal to the old number, then what we're going to do is we are going to break. So this will exit the current loop. So I'll just put a comment here. The break exits here. And then the only other thing that I need to do is at the end, the old number is going to get the value of the number. So before I enter another one, another new one, I have to store what the old one was. So now when we run this program, it's going to work like this. So it's an infinite loop. So I'm going to put in 3, then 6, and then 12. And then if I put in a 5, it stops running because of this break. So if this is true, usually I put a break, you know, in an if statement because I don't always want the break to happen. And then it drops you right here. This gets a little bit more confusing when you've got a loop inside of a loop. It'll exit you to the, past the current loop that you're in. And we're going to see a little bit of that later as we do more complicated loop structures.